So in this question, it asks, an analytical chemist weighs out 0.067 grams of an unknown triprotic acid into a 250 ml volumetric flask and dilutes to the mark with distilled water. He then titrates this solution with 0.1800 molar sodium hydroxide. When the titration reaches the equivalence point, the chemist finds that he added 11.4 milliliters of sodium hydroxide. What is the molar mass of the unknown acid? Now, this feels complicated, but molar mass is just grams per mole. So if we can determine the grams that we have, which is here, and using the titration equation, we can calculate the moles. If you have the grams per moles of any sample, you can then determine the molecular weight. So this one's a little different. So we also need a balanced chemical equation. So we have our acid, which we don't know what it is, but we know that it has 3 protons, plus NaOH, and this is going to go to we don't know. But the thing that we know is if we have 3 of these, then we have to have 3 of the sodium hydroxide to make our unknown salt plus 3 water, H2O. And so we don't need to know what X is in order to do this. We did need to know that it is triprotic. This means that it has 3 protons before whatever the compound is. So now in our first part, we're going to determine the moles. So we're going to have the moles of the known. So first I'm going to take my 0.0114 liters of NaOH, and I'm going to multiply that by the molarity of 0.1800 moles in 1 liter. And then I'm going to go directly into step 2, which is the moles of the unknown. And so here we know that there are 3 moles of NaOH for every 1 mole of acid. And this is our unknown acid. And so this gives me 0.000684 moles. So the question asks for the molar mass. So if we know that we have 0.067 grams, and that is equivalent to 0.000684 moles, when you plug this in your calculator, you're going to get 97.95 grams in 1 mole. And per the significant figures, that is going to round to 98 grams per mole. So this is just a slightly different version of the final calculation.